Okay, so the exercise 4H question 2. Question 2. Evaluate the line integral f dot dr. This is line integral of vector field. Okay, we look at questions A, where f is 2 dimensions, the f x y. You have the y cubed plus 1i plus 3x, 3x y squared plus 1j. Okay, where the C is semicircular curve. Semicircular curve from 0, 0 to 2, 0. Okay, first of all, we evaluate it, as usual, and then later on we test whether this one is, vector f is conservative. So first of all, we draw that curve to see, you got, let's say here, it's 0, 0, then 2, 0, x is 2, y is 0. Okay, semicircular curve. Why call semi? 0, 0 to 2, 0. Oh. Okay. So in this case, they are semicircular. So from 0, 0 to 2, 0. You notice that your circle, this one, normally what we have is like this types, right? Then you can use your x is the, let's say, r cos t, y is r sin t. X is r cos t, y is r sin t. But now your semicircular, is from the 0, 0 to 2, 0. So how to get the parametric equation will be quite challenging, because you need to, before you can get the parametric equation, in this case you cannot use this one. This one provided your circle is here, is centered at origin. If you use x equal to r cos t, y r sin t, provided your the center of the circle is centered at origin. Now this one is centered at here. Centered at x is 1. So how to get the circle equation? So you need to find back how to get the circle equation. If difficult to get the circle equation, then we cannot get what is a x in term of t, and then what is a y in term of t. In that case, let's try to check whether f is conservative, because this case difficult. We First of all, you need to get the circle equation. Then after you get circle equation, then you can let whether x is t or y is t. Then you can get the parametric equation, so that you can evaluate the line integral of vector field. If this case is difficult to get, a little bit difficult, then we try to check whether f is conservative. So for 2D, also doesn't matter whether to check whether f is conservative. You find the curl of f, this one. We use this form. This is the component I, component j. First column, first row you del del x, and then second column you del del y. Put f, component I is y cubed plus 1. Component j is 3x y squared plus 1. And then do like you're doing your determinant, main product of main diagonal minus the product of the other diagonal. Then what you need to do is you del del x 3x y squared plus 1. Then minus delta y cubed plus 1. Okay, when you delta x, y is constant. That's why delta x 3xy squared, you have 3y squared. Delta x1, you have 0. Okay, delta y cubed, we got 3y squared. So we get 0. Okay, remember, okay, this is I cross j, you get k. So you get actually it's a 0, okay, 0 vector. So, okay, this is called curl, okay, of f. Okay, if curl of f you get 0 vector, then f is conservative. Okay, since curl of f you get 0 vector, okay, 0 vector, then vector f, okay, is conservative. So make sure you understand the concept. Okay, because we have a following, we have the quiz, okay, testing on your concept. Okay, since f is curl f equal to 0, then f is conservative. Okay, therefore exists okay, one potential functions called, okay, phi. Okay, potential function phi, okay, such that such that f equal to del phi. Okay, when curl of f equal to 0, exists one potential function such that the f, okay, vector field f equal to del phi. Okay, then, okay, we are going to use this potential function to evaluate the line integral. Okay, because when f is conservative, it's either you use the simplest path or you can use a potential function to evaluate the line integral. Okay, I will choose to use a potential function because it's difficult to get the parametric equation for this curve. Okay, and then where f, okay, put in this from f equal to del phi. Okay, I put into this notation for your vector. Okay, component I, you have y cubed plus 1. Component j, you have 3x y squared, 3xy squared plus 1. Okay, del phi is, okay, del phi del x. Okay, if f is 2-dimension, then del phi also 2-dimension. So this is component j is del phi del y. Okay, then you equal component I. Component I, you have del phi del x equal to y cubed plus 1. Okay, our task to find the potential function. Okay, to find the phi, to okay, eliminate this delta x, okay, you have to integrate both hand side. That's why you get phi. Because when you integrate this one respect to x, okay, integrate and differentiation will cancel, you get the phi. Okay, and then this side also you have to integrate respect to x. That's why phi is actually integrate, okay, y cubed plus 1 dx. And this is partial integration. When you integrate respect to x, y is constant. That's why integrate total, this one is all are constant. So you have a x y cubed plus x. Okay, plus the constant is into a function of y. So this is the first equation. Then from component j, okay, when you do del phi del y equal to equal component j, del phi del y equal to 3x y squared plus 1. Okay, so similarly, you can also obtain the phi, okay, if you integrate respect to y both hand side. Because when integration meet with differentiation, it cancel out. That's why you obtain the phi is actually integral of 3x y squared, okay, 3xy squared plus 1 dy. Okay, so this is partial integration. When you integrate respect to y, x is constant. X is constant. That's why you have 3x. You factor out, you integrate, okay, y squared dy plus you integrate 1 dy. You got 3x. Integrate y squared dy, you have y cubed over 3. Integrate 1 dy, you have y Okay, when you integrate respect to y, x is constant. Okay, let's say I put gx. So this is the equation 2. Or you simplify your equation 2 first. Here you get, this is x y cubed plus y, okay, plus gx. This is number 2. Okay, so phi, okay, you can combine equation 1 and 2. So phi, okay, is a function of x and y. Okay, start from equation 1, take out, okay, you have the x y cubed plus x. Okay, and then function of y, say plus function of y, is actually you refer it to the second equation, which is y. So fy actually equal to y. That's why phi is xy cubed plus x plus y. Okay, and then you want to plus k also can. If you start from equation 2, phi you see xy cubed plus y plus gx. Okay, gx function of x. Okay, can you understand? Mean don't add up. Either you start with equation 1, locate function of y into second equation, so you get y. So okay, if you start from equation 2, gx actually refer to x. So mean xy cubed plus y plus x. Okay, or another way mean you start from equation 1, take out all the term from equation 1, add up the new term from equation 2, then you plus k. Or you don't, okay, if you don't plus k also doesn't matter because later on will be cancelled out. Okay, so this is a potential function phi, and then the line integral f dot dr along the curve C. Okay, you can use the potential function phi xy. Okay, okay, using the potential function phi, and then so I put out here your x y cubed plus x plus y plus k. Okay, lower limit is a starting point which is 0 0. Ending point, upper limit is the ending point which is 2 0. Okay, then you may quickly using a scientific calculator or evaluate it manually. Okay, hold on, I show you. Okay, I will use your scientific calculator. Alpha x alpha y cube plus k alpha x plus alpha y k, no need because k you cancel out. So xy cube plus x plus y. Okay, I calculate. Okay, upper limit, x is 2, y is 0. Your answer is 2. Okay, you plug in 0, x is 0, y is 0, everything is 0. Actually, you got 2 plus k minus 0 plus k. Okay, and we obtain the answer is 2. Let's check question 2a. Answer is 2. So question 3, given a force field Fxy equal to 3x squared plus 6xy squared I plus 6x squared y plus 4y squared j. Prove that F is conservative. So this is a guided question. So if question 2a, 2b is open, up to you to use the simplest path or potential function. But here you have to follow the instruction of the question. Then you have to prove whether F is conservative. So question 3. Question 3. Let's see what is the F. Okay. Okay. F can I write in this notation for the vector 3x squared plus 6xy squared for component I. Component j is 6x squared y plus 4y squared. Okay, question A, prove that F is conservative. Okay, and just now, okay, sorry, the notation, okay, curl of F, okay, when the example question 2, okay, I left out the cross there. Okay, this one I left out the cross. Okay, because del is a vector. So okay, f is vector, so it's a cross product. So del cross f. So here del cross f. Okay, phi is scalar, so del phi. So vector multiply scalar, result is vector. Okay, vector cross with vector, the result is vector. Okay, so f equal del phi. Phi is a scalar function. So prove that f is conservative, then you need to find the curl of f. Okay, this is an inverted triangle. This is called del cross f. Okay, two dimensions. So you have two columns. First column is I, second column is j. So first row, del is actually del xi. If f is two dimension, del is two dimension. So okay, column I, component I for f is 3x squared plus 6xy squared. Okay, component j is del y. Put out component j for vector f, 6x squared y plus 4y squared. Okay, then doing like you do the determinant of your 2 by 2 matrix. So del x, 6x squared y plus 4y squared. So minus del y 3x squared plus 6xy squared. Okay, when del x, okay, you can highlight when del x, y is constant, so constant. So that's why del x, 6x squared y we have. Okay, 6y is constant, you factor out, so mean you got 6y, then you del x, x squared. When you del x, 4y squared, you have 0. So this one, 6y, this is 2x. Yeah. So when you del y, x is constant. So differential constant, this term is 0. So 6x is constant. Okay, so you can factor out 6x and then you del y, y squared. So del y, y squared, you have 2y. Okay, so total 12xy minus 12xy. So you have 0k. Because I cross j, you get k. So del cross, okay, the curl of f will get 0 vector. Okay, since del cross f, you get 0 vector. Okay, thus f is conservative. Okay, question A. Prove that f is conservative. Proof. Show that the scalar potential function for phi. Okay, they give you the phi there. Just need to show you obtain this answer. Okay. So question B. Okay, when f is conservative, f equal to del phi. Okay, so put up the f. Okay, what's the f that we have? 3x squared plus 6xy squared for component I. Component j is 6x squared y plus 4y squared. This component j. Okay, del phi is del phi del x. Okay, del, make sure it's this. I don't use this one. This is called delta because I saw your assignment question 2. Some using this one. This is called del. This one is delta. So del phi del y. Okay, and then you equal component I. Del phi del x. You have 3x squared plus 6xy squared. Okay, to get the phi, you integrate dx both hand side. That's why phi xy. Okay, you integrate 3x squared plus 6xy squared dx. Okay, So integrate 3x squared, you have x cubed. So when you integrate respect to x, 6y squared is constant. That's why I got 6x squared y squared divided by 2. Okay, plus function of y. Yeah. And x cubed, okay, 2 and 3. So we get 3x squared, okay, 3x squared y squared plus function of y. Okay, this is the first equation. Okay, and then from component J, you have del phi del y. Okay, del phi del y equal to 6x squared y plus 4y squared. 6x squared y plus 4y squared. Okay, and then to get the phi, you can also, okay, to eliminate the delta y, you integrate respect to y. So you integrate respect to y, both hand side. Okay, that's why phi xy is integrate 6x squared y plus 4y squared dy. Okay, so when you integrate respect to y, x is constant. Okay, integrate respect to y, x is constant. So this is constant. That's why you have 6x squared and then y squared divided by 2. Okay, integrate respect to y, so you have 4y cubed over 3 plus function of x, which is a constant. Okay, simplify it. So you have 3x squared y squared plus, okay, 4 over 3 y cubed plus hx. So this is the equation 2. Okay, the phi xy, okay, start from equation 1. Take out, okay, all the term. You have x cubed plus 3x squared y squared. Fy, okay, fy is actually function of y. Is it already? Yeah. Okay, fy plus 4 over 3 y cubed, and then, okay, hx, because you start from equation 1, x cubed plus 3x squared y squared, function of y refer to 4 over 3 y cubed. Okay, this one already have, don't take it. Okay, this time don't take it. This is a new term, take it. Hx, hx, okay. Okay, so this is a potential function phi. Correct. 3x squared y squared plus 4 over 3 y cubed plus x cubed plus k. Okay, 3x squared y squared 4 over 3 y cubed, okay, plus x cubed. So you obtain the potential function, okay, phi. Compute the amount of work done against the force field F in moving an object from point A 10 to B 01. So mean use B potential function to evaluate the, okay, work is actually given by the line integral of vector field. Okay, mean C is actually work given by F dot dr along curve C. Okay, F is conservative vector field, then we use the potential function phi, which is x cubed plus 3x squared y squared plus 4 over 3 y cubed plus k. Okay, evaluate it starting point 10 and then ending point 01. Okay, so 10 and then 01. Okay, I will faster quickly using the calculator. So alpha x cubed plus 3 alpha x squared alpha the y squared plus 4 alpha y cubed divide 3. So x cubed plus 3x squared y squared plus 4 over 3 y cubed. K, because it will cancel out. Upper limit deduct, lower limit cancel out. So I calculate, okay, upper limit x is 0, y is 1. Get 4 over 3. Okay, 4 over 3 plus k minus, okay, so calculate, okay, lower limit x is 1, y is 0, get answer is 1. 1 plus k. So you obtain the answer, okay, 1/3. 4 over 3 minus 3 over 3, the answer is 1/3. Okay. So question 3C, okay. Okay, answer 1/3, correct. Okay, so 3C done. This one done. Okay, and then question D is that the value of line integral f dot dr along the two straight line from 1 0 to 0 0 and from 0 0 to 0 1 the same as the result in part C. Give your reason. Okay, we ask. Okay, Hadi, is it the same? Okay, so since KF is conservative vector field, so okay. Hey, hold on. Okay, this one, you see, starting 1 0, this is to 0 0. The answer is no, because we said answer is the same provided you have the same starting ending point. Same starting ending point, but you can have different path. Like question here, 2A here. You have semicircular curve, let's say here 0 0 to 2 0. Okay, this is C1. Okay, question 2, just now we have shown that F is conservative. F is conservative. And we face difficulty, a little bit difficulty to find parametric equation along curve C1. Along curve C1. Then we can use curve C2. C2, the equation is easy because y equal 0, x equal t. Then t from 0 to 2. C1, a little bit difficulty to find the parametric equation. You want to find, also can. Okay, and then f is conservative. We find f using del phi. We can also using potential function phi. Then we said when f is when curl of f equal to 0, f is conservative, then line integral is independent of path. But provided starting endings same, starting ending must be same, so you can have different path, the answer will be same. That's why question 2A, we can use a curve C2 along the x-axis, easy, or use potential function phi. Okay, and then but here is that the value of line integral along two straight line 1 0, but this one different point. Because you see here, this point 1 0 0 0, this one 0 0 to 0 1, the same as the result in part C. Okay, because starting ending this point, this one 1 0, this is 0 1, this is 0 0, different. This one starting ending not the same, so the answer is not the same, because even though f is conservative, but their starting ending point different. Okay, the answer actually wrong because okay, they get okay, this module give the wrong answer because okay, you got okay different starting ending. So please take notes on this one. This is no okay, no because okay, you got different starting and ending point. Okay, you have different starting and ending point.